Hi guys, welcome to today's lesson. So today we're going to be focusing on linear equations, right? But firstly, we're going to look at what is an equation on its own, and then how does it then become linear? And then we'll also look at, are there any other different equations that we need to know out there? How many solutions do they have? Are they able to be solved? All of those questions, we're just going to try and answer that in this particular lesson. But for now, let's look at our leading question for this particular lesson. So, have you ever thought about what is the difference between an expression and an equation? Remember, we've been talking about a whole lot of things that have to do with an expression, expanding, factorizing, and all of those other things. But now, how does an expression become an equation, right? How many solutions does it have? Is the solution of an equation the same as the solution of an expression? What makes them different? What relationship does an expression have that makes it different from it being an equation? All those questions is what we're going to try and answer in this particular lesson. But firstly, let's look at our map. Our map is, we're going to look at what we call algebraic equations. There's different types of them, although for you it will only be certain types that you're going to focus on and not all of them. We have linear, we have quadratic, we have literal, we have cubic, hyperbolic, and an exponential equation, right? So all of these are different types of equations. There might be some that are left out, but it might be just because we don't really do them in our syllabus. Now, we're also going to look at solving linear equations, and there will be three main concepts that you need to know there, which is the additive inverse, the multiplicative inverse, and the reciprocal. The keywords for this lesson is, remember I said, we're going to look at firstly, what is an equation? And then, what makes an equation to then become linear? What does linear mean even? That's the other thing that you can even think about. When I say something is linear, what is it that it means? Now, an equation, according to mathematics, it will be a mathematical statement consisting of an equal symbol between two algebraic expressions. So we've been looking at all these expressions, right? If I have one expression, another expression, in between them I have an equal sign. We then call it an equation. And most of the time, what you need to know about an equation is it represents a relationship between two expressions, because that equal sign in between means that this expression must be equals to this expression, right? So that's why the equal sign is between the two expressions. Now, the equal symbol means that the two algebraic expressions have the same value as I just said now. Now, an example of this, I just want you to know the different language or vocab that we use for an equation. So if I have 5x plus 9 equal to 24, firstly, the 5x plus 9 is just an expression. The 24 is just an expression. The equal symbol means that the expression on the left must be equals to the expression on the right in value. But let's look at what is the expression on the left. The expression of the left, on the left rather, has what we call a coefficient, which is normally the number in front of a variable. It has what we call a variable, which you guys know it as alphabet. When we started doing language, we spoke about alphabet. So we use X most of the time in math, but it's not the only one. And then we have what we call a constant. A constant will be a number on its own. Even 9 is also a constant. So it's not only the 24. And then lastly, my equal symbol, as I said. Now, the different types of equations that I just want to show you. Linear will be the one that I just showed you now. So let me show you. A quadratic equation can be x squared plus 2x equals to 3, right? This is a quadratic equation. Why quadratic? Because of the exponent 2 there. We're going to go to linear equation and see exactly what makes it to be linear. We also have a cubic equation which can be x cubed is equals to 8, right? X cubed equals to 8. Because of the 3 there as the exponent, we call it a cubic equation. We also have a hyperbolic equation which will be like 2 over x minus 2 equals to, you can say, 5. This is an example of a hyperbolic equation. And then lastly, the exponential equation, the literal, we'll talk about it at a later stage. The exponential equation will be 2 to the exponent of x plus 1 equals to 16. It doesn't really matter. These are just made up things, right? But they are mathematically correct. Exponential because the variable is part of the exponents. That's how we call it an exponential equation. But for this specific lesson, we are only focusing on the linear equation. Linear equation will be an equation of one variable that has a power of 1. Why am I saying a power of 1? It means that the highest exponent is 1 of all the variables that we have. Then lastly, a linear equation has only one solution. That's the very main thing that you always need to know there. Now, when you say, quickly just back to the one that we did, we said it was 5x plus 9 equals to 24, right? This has an exponent of 1 there. That's what this means, to say it has a power of 1, and it will always just give you one answer or one solution when you are trying to solve this particular question. So if we try and solve this, which I will give you a step-by-step breakdown later on, you will just say this is 5x. I'm sure by now you have done this. 24 minus 9, it becomes 5x equals to 15, and then lastly I will have x as equals to 3, right? But for now, don't really worry about the steps of getting there, because we are going to break it down very soon as to what are the few steps that I want you to write down in order to be able to solve any linear equation, no matter how it looks. And trust me, some of them might look very dangerous and very scary to say, how do I solve this? But it's very possible to do that. But for now, let's take a quick ad break and I'll be back with some more. Stay tuned. Hi guys, welcome back from the ad break. I hope you are refreshed. Now, I want you to pay close attention to almost everything that we're gonna do now. Take down notes, make sure that you ask questions on your notes there that you will go back and research about if you don't understand some things, because that's how, after all, you practice anything, right? If you don't understand a certain note, just make a question mark and then go consult your textbooks, Google, everything that has information that you can find under mathematics. But for now, I want us to look at some principles that are involved in solving linear equations. And those principles is what you call the additive inverse number 1, the multiplicative inverse number 2, and lastly what we call a reciprocal. I know that some of them you've done them at lower grades when you are doing your mathematics. Now when you talk about an additive inverse, or rather additive inverses, these are two numbers that add up to 0. So if I want an additive inverse of 3, it means that is minus 3. If I want an additive inverse of minus 3, that is plus 3. I want an additive inverse of x, that is minus x, because I must always get 0 as my final answer, right? That's what adds up to 0 means. The numbers, these additive inverses are numbers with the same size or a term with the same size, but the most important thing is the signs must be opposite. It can't have the same signs as well. One must be plus, one must be minus at all times. After all, additive inverse has to do with plus and minus only. So when two additive inverses appear in the same equation, the sum is always going to be 0. Because remember, I just said additive inverse is about plus and minus, and it must be numbers that always add up to 0. So if you see both of them in one question or one equation, the answer must definitely be 0. Now, let's just look at an example of what this means, right? If you look at the 3x and negative 3x, you can already see that these will subtract each other and give us 0. Similarly with the 2 there and the negative 2 there, they will subtract each other and give us 0. So you remember associative property, if you group them in any way, it still gives us the same thing. So this will be the same as 3x minus 3x plus 2 minus 2. 3x minus 3x will be 0. 2 minus 2, will also be 0. So my answer will just be 0, right? So you can see at all times when you have two additive inverses that appear in a certain question, then it will definitely give you 0 as your answer. We also have what we call the multiplicative inverse, right? The multiplicative inverse has to do with multiply and divide, right? Multiplication and division. So this is the multiplicative of a number is the second number that gives the answer to be equal to 1 when these two numbers are multiplied together. So if I have a, whatever that I multiply a with, I must always get 1 for it to qualify to be called a multiplicative inverse. So you know this will be the same as 1 over a, and that will give me 1. But I'll show you exactly what this means. Now, a typical example will be me having the question as just the 3 over 4x. That's my question, right? And I want to show you what the multiplicative inverse of this will be. It will then be the 4x over 3. Why? Because the 3 and the 3 will divide, the 4x and the 4x will divide, and this will give me an answer of 1, as the instruction said. Or some people prefer multiplying the numerator with the numerator, which will give me 12x over the denominator with the denominator. It will also give me 12x, and then my final answer will be 1. So at all times, you must get 1 as your final answer. And I will give this additive inverse, a multiplicative inverse of mine, a name at a later stage, just so that when we are saying these words, you're then familiar with the concepts that you are going to use. And the name that I'm just talking about is what we call a reciprocal. So the reciprocal will always be written as 1 over the number. So to get a reciprocal of a number, we divide 1 by that number. So going back to the question that I just did now, I said the multiplicative inverse is 4x over 3. Let me show you how we got that. So my number is 3 over 4x, right? And I said for you to get the reciprocal, you must divide this by 1. Or you must say 1 divided by the number I mean. So it will be 1 over 3 over 4x. And then you know this is the same as 1 divided by 3 over 4x, which is the same as 1 multiplied by 4x over 3. That's where the 4x over 3 comes from. So we call this the reciprocal. So it's either a reciprocal or a multiplicative inverse. They both mean one thing. So let's look at the steps that I want you to follow when solving linear equations. Step 1, you are to expand the brackets and collect like terms. Whenever there is brackets, you know, Bodmer says always get rid of the brackets. What does get rid mean here? It means you expand by multiplying inside the brackets using the distributive property. So minus 4 multiplied by k, minus 4 multiplied by 2, and then the right-hand side will remain. So this will give me 3 minus 4k minus 8 equal to 3k plus 16. That's number 1. Number 2, you then group variables on the left-hand side of the equation and the constants on the right-hand side of the equation by adding the additive inverse on both sides. Now, I know that most of the time we are told that take it to the other side and it changes the sign. Really, it kind of means, it means one and the same thing, right? But mathematically, it's you taking the additive inverse on both sides. So if it was a plus 3 and you want it to be 0, it must be minus 3, right? Because I'm trying to get rid of it on one side and take it to the other side. So I must subtract 3 on both sides. So this one will therefore mean I have 3 there as I showed you, I have 16 there, I have minus 8 there. All of them must be on the right-hand side. So 16 is already on the right-hand side, so I'm not going to touch it, right? But my 3 must disappear on the left-hand side. For it to disappear, it means it must become 0. So I must add the additive inverse of 3, which is negative 3, and that's there, right? I must also add the additive inverse of minus 8, which will then be plus 8. But remember, in maths, we always say what you do on the left, you must also do on the right. Why is that the case? Because if you only do it on one side, it means you have already changed the question itself. It's no longer what the question was, right? But if you do it on both sides, you can always reverse it and it goes back to the original question. So I subtract 3 and I add 8 on the right-hand side. So the 3 and the 3 will be 0, minus 8 and 8 will be 0, and then 16 minus 3 plus the 8 there will give me 21. And then now I have 3k on the right-hand side. But remember, what did I say? Every variable must be on the left-hand side. So I must add the additive inverse of 3k on both sides. So this will be negative 7k equals to 21. And then you apply what we spoke about as well, the multiplicative inverse. So, by the way, let me just tell you something about the multiplicative inverse. The multiplicative inverse is to reverse whatever the operation was there. So if the operation is multiply, the multiplicative inverse will be to reverse the multiplication using what? Division, because they are the opposites. If you have a division sign between the terms, then the multiplicative inverse of that will be in the form of what? Multiplication, to reverse the division at all times. So, between the 7 and the k, I have a multiplication there. What does that mean? I must multiply this by negative 1 over 7. Remember, I said you always say 1 over the number. But what you do on the left, you must also do on the right. 1 over 7. Or this is as good as you saying divide by minus 7, divide by minus 7. It really means one and the same thing. But I'm going to erase those so that then you don't see a lot of things on the board and you end up being confused. So if I simplify this, it is going to give me k alone. And then 21 divided by negative 7 will be the same as negative 3. And that will be my final answer there, right? So what does this mean? You multiply both sides of the equation by the multiplicative inverse of the coefficient, right, of the variable. So As I said, that's negative 1 over 7. And you must also do it on the right-hand side. And then at the end, I will get k is equals to, let me write that properly. I will get k is equals to negative 3. Now, one of the beautiful things when it comes to equations is that you can always test your answer whether you are correct or not. By doing what? By substituting the variable that you got, right? If you find that the left-hand side is equals to the right-hand side, then it means your solution is correct. Because remember, the equal sign means that both sides have the same value at all times. So if I do that, it will be 3 minus 4 in brackets. Remember, the value of k we said was minus 3 plus 2. And this will give me 3 minus 4 into minus 1, right? Which will at the end be 3 plus 4, which is equals to 7. Now, this gives me the left-hand side. I want to see whether the right-hand side will also be 7 or not. If it's not 7, then definitely what you did is incorrect. You must go back and relook at what you did. So this will be 3 into negative 3 plus 16. And then 3 multiplied by minus 3 will be minus 9 plus the 16 there. And if I work this out, then definitely I will get my answer as 7. So you can see that the left-hand side is equals to the right-hand side. So I can add one last step to my step 3. And that step will then be, after multiplying both sides of the equation by that, and you are getting your answer and you are all well and done and you think you are okay with your answer, the last step will be substitute the answer, or rather the value, right, into the original equation. The original equation. And what this means is you must always get left-hand side equals to the right-hand side. And that's what will inform you whether your answer is correct or not. If it does not give you this, then it means your answer is a lie, right? And you need to go back and revisit what you did there. So that's what you always need to do. So I can name this as step 4, just for you to always know that you have got the correct answer at the end of your working out. All right, guys, that's it from me for now. I hope you have enjoyed everything that we've done thus far. But for now, I want us to take a quick ad break and refresh a bit, drink some water, make sure that you come back refreshed. But for now, please stay tuned. I'll be back just now. Hi guys, welcome back from the ad break. So right now we're going to still continue with our lesson and looking at equations. But now we're going to look at equations that involve fractions, right? As scary as it is, it's really not, I promise you, because it's linear equations. When you get rid of all the fractions, you will end up at a linear equation which will give you one solution at all times. As soon as there is now a squared somewhere there, or a cubed or exponent 4, then it's no longer a linear equation. So please make sure that when you're solving it, you must see exactly that it is always just x on its own without an exponent, because as soon as it introduces an exponent, there's a problem there. So let's have a look at them. So the keywords here will be an algebraic fraction, And with algebraic fraction is what we call the LCD, which is lowest common denominator, right? If I have a few denominators, I must always have which one is the lowest, and that's what I will be using. So when you're adding and subtracting fractions, the first thing to do is to determine the LCD, right? The LCD of 4x, 3x, and 2x. You can see already there's a common x in all of them. So I will just say there's an x there. Now the coefficients, 4, 3, and 2. I need the lowest common denominator of all of them. To explain what the lowest common denominator is, it will be a number such that the 4 and the 3 and the 2 are divisible in without leaving a remainder. I will repeat that. The LCD will be a number such that the 4, 3, and the 2 are divisible in without leaving a remainder. Already x, x, and x are divisible in x, and they don't leave a remainder. So with that one, I am done. I just need for the 4, 3, and 2. Most of the time, you will see that if you multiply all three numbers, you will get your lowest common denominator, but it might not be really the lowest, because if I multiply the 4 and the 3 and the 2, so 4 multiplied by 3 is 12, by 2 gives me 24, right? All these three numbers are divisible in 24, but if I multiply the 4 and just with the 3, this gives me 12. 4 is divisible in 12, 3 is divisible in 12, 2 is divisible in 12. So between these two, the lowest will then be the 12. Another easy way of doing this is to list all the multiples of the numbers that you have. The lowest that appears throughout your list will then be the one that you choose. So I have 2. The multiples of this will be 2, let me say 2, 4, 6, 8, 10, 12, right? And then I also have 3. The multiples of this will be 3, 6, 9, 12, 15 continuously. I'm leaving it there because already I can see there's a 12 that's appearing and there's a 6 that is appearing on both my lists. But the last one now will be 4. The multiples of 4 will be 4, 8, 12, 16 already. You can see I have a 12, I have a 12, I have a 12. So that's what the lowest common denominator will then be here. So that will be 12. What do you do with the lowest common denominator? You multiply each and every term by the lowest common denominator in order to get rid of the fraction. So if I multiply everything here by the 12x, 1 over 4x multiplied by 12x over 1, the x and the x will divide, the 4 goes in 3 times there, so my answer will just be 3. So it means this will now become 3. It's no longer a fraction. It's a fraction though, but over 1. Look at the second one. If I multiply 1 over 3x by by 12x again, that will give me 4. And then lastly, if I multiply 1 over 2x by the 12x, this will give me 6. So that's how you then use the lowest common denominator. Now, firstly, when you are solving linear equations that include fractions, you are to find the LCD and then multiply both sides of the equation by the LCD, meaning multiply every term as I just said. So my LCD here, you can see it's straightforward. Is 3 divisible in 3? Yes. But is 6 divisible in 3? No. Is 6 divisible in 6? Yes. Is 3 divisible in 6? Yes. Is 2 divisible in 6? Yes. So it means 6 becomes the lowest common denominator here. So my lowest common denominator will therefore be 6. If you multiply this by 6 and also multiply this by 6 and also multiply this by 6, you will then get for the first one 2 multiplied by 4x minus 1 negative, and then 6 there will divide with the 6. It means this will just be the 7x plus 2. I'm including brackets because I'm minusing more than one term. And then lastly, the 2 goes in 3 times there, so this will give me 3x. Now you can see I don't have any fraction anymore. This is just the linear equation. So step 2 will then be to group variables on the left-hand side, remember, of the equation, and then the constants on the other side by adding your additive inverse to both the sides. So my additive inverse of minus 2 is negative 2, right? So let me just quickly check that. Oh, my minus 2 is part of the question, so it's not the additive inverse. So it means I will firstly simplify this. It becomes 8x minus 7x minus 4 equal to 3x, right? Because I want to group them accordingly. So this will give me 2x, x, just x, not 2x. So this will give me just x on this side minus 4, then plus 4, because remember I said you must add the additive inverse, is equal to 3x, which will then give me x. Remember to add a 4 on the other side. It will be x is equals to 3x plus 4. The additive inverse of 3x on both sides will be minus 3x, and it will be minus 3x on this side. So this will then give me negative 2x is equal to positive 4. And then the last thing that you always need to do, multiply both sides of the equation by the multiplicative inverse. It means you multiply here by negative 1 over 2, and you multiply here by negative 1 over 2. So this gives me x is equals to negative 2 on that side. Now quickly let's test our answer whether we got the correct thing. Remember I said you must always try that. If I substitute the negative 2 there, it will give me 4 into negative 2 minus 1 over 3 minus 7 into negative 2 plus 2 over 6. If you simplify this quickly, the 4 multiplied by negative 2 will be negative 8. Minus 1 is minus 9. So it will give me negative 3 as my answer there. 7 by negative 2 is 14, which is a negative, plus the 2 is minus 12. Divide by the 6 will be a negative 2, but there's still that negative, so it becomes plus 2, which is equals to minus 1. Then that's the left-hand side. The right-hand side will be minus 2 over 2, which is definitely equal to negative 1. Therefore, the left-hand side is equals to the right-hand side. That qualifies our answer to then be correct, and then I can mark it right. Guys, I hope you are still enjoying and you are having so much fun like I am doing with all this algebra that you are busy doing. But for now, let's take a quick ad break and I'll be back with some more. Hi guys, welcome back from the ad break. Now we are on our last segment for the show. This is when we are just going to apply all the rules that we've been talking about. Guys, remember that I said always add the fourth step, right? Which is taking the answer that you got and substituting it into all the equations that you were initially given, right? Meaning the original equation rather, and then find whether the left-hand side is equal to the right-hand side. If it does not give you that, then it means there might be something that you did wrong. It might be an issue of a glitch with the sign, or it might be you added incorrectly, or you added the wrong number. But it is just always that minor mistake that you can quickly go back and fix. That's what they mean when they say check your answers. But for now, let's look at solving algebraic equations that have fractions, right? And try to see how do we apply all these laws that I've been talking about. Let's look at it. So the question will always be solve the following equation. Now, guys, I'm looking at this and I'm thinking to myself, here, this looks so complex. Will you even be able to do this? But very much so, you will be able to do this. Why? Because you will first need to make sure that you factorize the numerator, and then you can then work it out, right? But what I will then quickly do here is to change a number for you so that this can be factorized properly. But we have something that before I solve that, we need to remember. The issue of tipping and timesing, right, when required. So when dividing a fraction, you always need to make sure that you tipping and timesing if it is two fractions, like in this example that I started with. Oh, by the way, I thought I'm going to change something. Now that I'm seeing it, I don't need to do that. So firstly, I will take out a common factor of 4, and this will be x squared minus 1. And all of this is divided by x plus 1. And then, because of this division sign there, I must change it to a multiplication, and I must tip and times my fraction there. So this will be multiplied by 4x all over 5, right? And this will be equals to 2 minus x. I don't need to do anything there. And then you then start solving this. On the numerator there, I can factorize that. So this will be 4 into x minus 1 into x plus 1. All of divided by x plus 1. I'm sure right now you are smiling there at home and thinking, hey, now I can see the light and I can see where we are going with this. So this will be 4x divided by 5 equals to 2 minus x. Now, I should just make a disclaimer that you will see that this is going to end up being a quadratic equation, right? Which we will then look at a later stage and use the factorization rules. So this and that I will need to divide because they are the same, so they will cancel out. And then I will be left with just the 4 into x minus 1 multiplied by 4x over 5 equals to 2 minus x, right? Let me just rewrite it here so that I have enough space. So I said it's 4 into x minus 1 multiplied by 4x over 5. Let me just verify. Yes, which is equals to 2 minus x. Now to solve this, I need to get rid of the fraction, meaning the LCD is 5. If you multiply everything by 5, this will be 20 into x minus 1 multiplied by 4x is equals to, if I multiply this side by 5, it will be 10 minus 5x. And then from there, I can try simplify this. Firstly, remove the brackets, meaning it is going to be 20x minus 20 multiplied by the 4x equals to 10 minus 5x. Now, this is all good and well, right? But as soon as I multiply that 4x in there, you can already see that this is no longer going to be what? A linear equation. It's now going to be another type of equation, which we solve normally using factorization, as we spoke about when we're talking about the expressions. So this will give me 80x squared minus 80x, and then minus, or rather, let me just write it as is so that we do it step by step and don't rush it. And then you add the additive inverse on both sides. Remember why? Because I'm trying to get the x to be on one side and the values to be on one side. So it means I must add 5x there. I must also add 5x here. So that will then give me 80x squared minus 75x equal to 10. Now from here you can see I have a squared there, so it changes this thing completely. It's no longer a linear equation. So because we are still dealing with linear equations, for this, if you were given this and it's under linear equation, you would say no solution. But because you were taught by me when we did the factorizations, it then means that you can then solve this problem without any hassles. And to do that, I will divide everything by 5 because that is my highest common factor here. If I divide the 80 by 5, it will then give me, what is my 80 divided by 5 now? So this will be, it will therefore give me 16x squared minus, this will be 15x, and this will be equals to 2. And then you can then start factorizing if this is you are able to factorize this, right? But I'm just going to leave it here. Why am I leaving it here? Because we are mainly focusing on linear equations. I was just trying to show you that at times, it will not be the linear equation that we think it will be, and we must make sure that we do follow all the rules. So if you find yourself at this point and you are only focusing on linear equations, it means it is that situation where you include no solution or not applicable in that particular context. But what if we remove the division sign and now put a plus sign? What does that mean for us? Let's have a look at it. So if I remove the division, same equation, same everything, I just removed divide and put a plus. This will then give us what we really, really want. So remember, firstly, it becomes 4 into x plus 1 into x minus 1, all divided by x plus 1, and then plus the 5x over 4 equals to the 2 minus x, right? And then I need to just simplify this. The x plus 1 and the x plus 1 will divide. It means I'm left with 4x minus 4. I just multiplied in the 4 plus the 5x over 4, and this is equals to 2 minus x. And then remember, you multiply everything by the LCD as we've been doing. So far I have 4x, just to rewrite it quickly, minus 4 plus 5x over 4 equals to 2 minus x, right? Then my LCD here will be equals to 4. If I multiply everything by 4, I will get 16x minus 16 plus 5x equals to 8 minus 4x. Here, now you can see that this is definitely a linear equation. So what do? Everything that has x to the left, everything that has a constant on its own to the right. So I will start with constants and then follow with the x's. So this will be 16x plus the 5x, I'm just going to group them, minus 16, then plus 16, right, equals to 8 minus 4x plus 16. And this will give me 16x plus 5x, there will be 21x, and then equals to 8 plus 16, let me just add it so that I don't add another step there. If I add those two, then I get 24 minus 4x. Lastly, you add 4x on both sides, so that will be plus 4x, and then plus 4x. So that will give me 25x equals to 24. And if you then divide both sides or multiply by the multiplicative inverse, it becomes 24 over 25, and that becomes my answer. Because it's a fraction, I'm just not going to then substitute it, but you definitely need to do that. The last step is to substitute this into the original equation. Now let's summarize everything that we've spoken about, guys, so far. Remember, I said you must make sure that you identify the type of equation that you are given, right? You saw the first one, it was a division, but it ended up being a quadratic, so it is not what we are actually focusing on. And then also simplify the terms, make sure that you work out your like terms, and subtract, add where necessary. The last thing you always need to do is to collect the terms with the variable on one side of the equation and the constants on the other, and then the last thing will be to solve. What I mean by taking them to one side and another side is to make sure that your left-hand side is always the variable. Why? Because when we read out our solution, it is always is equals to 5. Is equals to 5. So we always start from the left-hand side. That's why everything that is a variable must always go to the left-hand side, and then your constant to the right-hand side. And then my last golden step will be to take your answer, substitute it into the original to find out whether the left-hand side is equal to the right-hand side. If it is, then it means your answer is correct. From me to you, the maths doctor, mathematics is food for the soul. Until I see you next time.